To proactively catch errors in Python, you can manually raise exceptions. This is done using the raise keyword, followed by an exception type and an optional descriptive error message. You should use this when your code encounters an unexpected or invalid state that prevents it from proceeding correctly.
It's powerful for enforcing business rules, validating inputs, or ensuring preconditions are met, making your programs more robust and preventing silent failures. For instance, imagine a function requiring a positive number. If a negative number is passed, instead of silently continuing, you'd raise value error. Input must be a positive number. This immediately halts execution at the problematic point, clearly communicating the issue, allowing other parts of your program to catch and handle this specific error gracefully.
The order processing error class defines a custom exception specific to our application's domain, inheriting from Python's base exception. The process_order function encapsulates the logic for validating and fulfilling an order, acting as a core business operation. This function checks for several conditions like valid quantity and stock availability before proceeding. Inside process_order, raise statements are used to manually trigger exceptions when specific error conditions are met. For instance, raise value error is used when the quantity input is invalid, e.g., 0 or negative, indicating a problem with the arguments provided to the function. Raise order processing error is used for business logic violations, such as when an item_name is not found or there's insufficient stock, signaling that the order cannot be fulfilled under current conditions. This pattern ensures that calling code is immediately notified of issues, preventing incorrect state or further processing with bad data.
The _if_name_equals_main__. Block demonstrates how to use a tree, except to catch these manually raised exceptions. Each call to process_order is wrapped in a tree block, attempting the operation. If process_order encounters an error and raises either a value error and order processing error, the corresponding except block catches it. This allows the program to handle errors gracefully by printing a descriptive message rather than crashing, illustrating a robust way to manage expected failure scenarios in an application.